Okay, how do I differentiate such a complicated function? So I have to differentiate well, it seems you are not comfortable with differentiating with respect to delta t. Are you comfortable with taking derivative with respect to delta t? What if I replace delta t with x, just introducing new notation? So I differentiate the function cosine inverse of f prime of t0 dot product f prime of t0 plus x divided by magnitude of f prime of t0 times f prime of t0 plus x. And just replacing the variable with a different notation. So now this is a function of x, and I have to differentiate with respect to x. So what do I do?
Quotient rule.
Quotient rule. Do I go immediately to quotient rule? Is that quotient the whole thing? No. It's cosine inverse of quotient. So how do you differentiate?
The difference was on the inside of the entire.
Yeah, the chain rule, right? That's what you use. All right. So to differentiate this with respect to x, I have to differentiate cosine inverse. Now tell me please, what is the derivative of cosine inverse? Does anybody remember?
1 divided by square root of.
It is 1 divided by square root
X squared plus 1.
x squared plus 1. So 1 plus, let's say, question mark squared. Because that should not be x, that should be the whole fraction, right? That's what I have to substitute into that argument. Okay. So let's, instead of question mark, I will put those brackets and a fraction, but I will not fill in what it should be there. Okay. And then this should be multiplied by derivative of the inside with respect to x. Okay, so what do we see inside? We see a fraction. So we apply the quotient rule. I know the quotient rule. It's the square of denominator. So that is magnitude of f prime of t0 squared times magnitude of f prime of t0 plus x squared. And now I have to write down the numerator. What is that? The derivative of the numerator here, right, times the I thought it's derivative of top times the bottom minus.
Yeah.
So what's the derivative of the top? What do you see on the top? You see a dot product, right? So how do you differentiate that dot product? Is there a dot product rule? No dot product rule?
Well, can't we say that since it's distributive, we can use
The usual product rule, right? So there's nothing special about the dot product rule. It satisfies the usual product rule. So the product rule says that it's derivative of that times this. Derivative of that is what? It's 0, right? This is a constant. Plus that f prime of t0 times, and times means the dot product, right? Times derivative of that. What is that? Derivative of f prime of t0 plus x with respect to x. Well, it's a double prime. f double prime of t0 plus x. By the chain rule, you have to multiply by derivative of the inside with respect to x, which is 1. So I stop there. This is the derivative of the numerator. I have to take that, multiply it by the whole denominator. Magnitude of f prime of t0 times magnitude of f prime of t0 plus x. And then subtract. So my fraction continues here. I subtract the numerator, which is dot product, f prime of t0 dot f prime of t0 plus x. The dot product multiplied by derivative of the denominator. So what do we see in the denominator? What kind of product is that? Is that dot product? Look at this. Don't you see that this point is different from that point? You see the difference? This versus that. Let me make it bigger to emphasize the difference. What kind of product is this? Well, this is a number, that is a number. This is just scalar multiplication. Right? You just use the same dot, but everybody in calculus 3 must see the difference. Right? So this is product of numbers. That number is a constant. So derivative of the whole thing is just that constant, magnitude of f prime of t0, multiplied by derivative of that magnitude. And unfortunately, I don't know yet how to differentiate the magnitude of a vector. We did it some time ago. So let me leave it as it is now. F prime of t0 plus x. This magnitude differentiate.